All right, good afternoon, everybody. So in the last lecture, we were talking about creating classes, and we were in the middle of implementing some constructors and methods for our classes. Right, so we've got three classes that we're working with. We've got our point class, our counter class, and our stopwatch class. So for the counter class, we want to add a constructor. Right? So the no argument constructor should initialize the counter so that its value is 0. Right? So remember, our counter class only has one field. Right? It's just the primitive value value. Right? Our counter constructor should initialize all of the fields of the class. So there's only one field to initialize, and we're going to set it to 0. Right? Now remember what the keyword this means inside the constructor. Right? So the keyword this, that's just a reference to the object that's currently being initialized. Right? So when you make a new counter, when we make a new counter and create a variable c that refers to the counter, right? The variable c appears in memory. Right? New allocates memory for the counter object. Right? The way it does it is it takes the counter class, copies it, and puts the copy somewhere in memory. So there's our copy of the counter class. Right? When it copies the class, the object gets its own value field. The constructor begins to run. So when the constructor runs, it gets passed the address of the object that was just created. And that value gets stored in the parameter called this. Right? So this is just a reference to the object that was just created. Right, now the constructor runs, so the constructor does this value equals 0. So what's this? Well, this is the object at address 550. Right, so this value is this field right there. So that value gets set to 0. And then the constructor finishes running. That lets new finish running, and then new returns the address of the object back to, new returns the address of the newly created object. So C gets set to 550A. Okay, what about the stopwatch? So for the stopwatch, no argument constructor, we have to set the start time, the stop time, and whether or not the stopwatch is running. Right? So we're going to set the start time to 0, the stop time to 0, and the watch will not be running. So that's easy. Right? So the start time is 0, stop time is 0, and the watch is not running. Right? So normally the constructors are straightforward. Well, is that true? For these simple classes, constructors are easy to implement. Right? All you're doing is assigning a value to each one of the fields. Right? In a more complicated class, you might have to do some sort of validation. Right? So you might have to test, is the value that's passed into the constructor valid or not? And you might have to do some more complicated setup. But yes, question? What's 0L? 0L. So L is 0 as a literal is the integer value 0, the int value 0. If there's an L after it, then it's a long literal. Right? You don't actually need the L here. I'm just putting it here to make it clear that it actually is a long value. All right, what about methods? So we have a constructor now in each one of our classes. If we want our objects to actually be able to do something, we have to provide methods as well. A method just performs some sort of computation. Right? Now, so far all of our methods have been static, but that's going to change now. Right? So now most of our methods will become non-static. Right? So non-static methods, you need an object to call that method with. Right? Static methods, you just use the name of the class. But as soon as you create a class where you're making objects, then it tends to be the case that most of your methods now become non-static because you want to call the method with an object because that object has its own state. Right? So in other words, typically you're calling methods to either ask an object about its state or to change the state of an object. So now our methods are non-static. A non-static method is able to use any field belonging to the object. Right? So for example, we can provide a non-static method that allows the user to set the x and y coordinates of a point. Right? So back in the point2 class, right? So inside point2, right? So class point2, we've got our constructor and fields. Right? We can add a method called set. Right? Set changes the coordinates of the point to new x and new y. Right? So how do you change the coordinates of this point? Well, this dot x equals new x. Right? How do you change the coordinates of the y coordinate? Well, this dot y equals new y. Right? Whatever you do here, don't flip the order. Right? So don't write new x equals this dot x, new y equals this dot y. Right? What that does is it changes the value of the parameters, new x and new y, and it doesn't change the coordinates of the point. Now, we've got an unusual method here. So the implementation of this set method returns a reference to a point2 object. Right? And the reference it returns is a reference to the object that was used to call set. Right? Now, the reason I'm doing this here is because, number one, you don't often see it, especially in an introductory programming course. Right? But number two is it turns out to be very useful, especially for things like points. Because points are, you want to treat them as though they are mathematical objects. So we're going to want to do things like add a vector to a point, multiply a point by a scalar, and so on and so on and so forth. Right? If you want to write down an equation involving points, like p equals p plus v times something, right? And you don't return a reference to the point, then what ends up happening is every time you do an arithmetic operation, you need one line of code. Right? If you return a reference to the object, then that lets you chain method calls like this. Right? So if set returns a reference to the point, right, then p.set changes the coordinates of p to 1, 1. Right? And now you can use that reference, which is just p, to call some other method. Right? If that some other method also returns a reference to the point, then you can chain it again. So dot some other method. Right? And so for objects where you want to do arithmetic, this turns out to be really handy. Right? Because then you can do something like p dot multiply by something, dot add something, dot subtract something, and so on and so on and so forth. Right? Instead of writing each method call out on one line. And so that's why we're returning a reference to this back in this method here. Question or? OK. OK, so you can also provide a method that allows the client to just change the x coordinate of the point. Right? In many classes, this will be called set x or set something. Right? I'm just calling it x. Right? So mutator methods are often called setter methods. And they often begin with the word set. I'm just going to call it x. Right? You take in a new x value, and it changes the x value of the point to new x. Right? I'm also going to return this in this case so that, again, the user can chain calls to this method. Right? So p.x, some new value, dot y, some new y value, and so on and so on and so forth. Right? And again, you can just like that method there, you can write a method that changes the y coordinate of the point. Right? And it's exactly the same thing. OK, so those three methods that I just showed you, those are all called mutator methods or setter methods. So a mutator method is a method that changes the state of an object. Right? So set, x, and y, those are all examples of mutator methods. What's this? Oh, accessor methods, here we go. So an accessor method is a method that returns information about the state of an object. Right? These are also called getter methods. So often they'll start with the word get. Right? So if you're making a point class, it's probably the case that someone using the class is going to want to get the x and y coordinates. Right? So we need to provide methods that return the x and y coordinates of the point. Right? Not surprisingly, I'm going to call them x and y. Right? So x returns the x coordinate. Right? How do you return the x coordinate? Well, you just return this dot x. Right? How do you return the y coordinate? Just return this dot y. Right? In Java, there's no way for me to return both coordinates at the same time. Right? Just like in C, right? Because you can only return one value at a time. OK, so when you create a method, the first thing you do is you write down what's called the method header. Right? And that method header can be made up of 5 different parts. Right? So there's a modifier or modifiers. There's the return type, then the method name, then the parameter list. There is sometimes a throws clause, but we're not actually going to use those in this course. But you will occasionally see a throws clause at the end of a method header. Right? So your method header is just this thing here. Right? So it's just the declaration of the method. So at the beginning is typically one or more modifiers, so 0 or more modifiers. Right? So here the modifier is public, so that's an access modifier. Right? The keyword static might be there as well. That's in which case that indicates a static method. There are some other modifiers, but we don't use them in this course. And they're also much less common to see. Right? So the next part is the return type. Right? So that's the value, the type of value that's returned by the method. Right? So it's either some type or it's void. Right? So void for a method that returns no value. Right? Then the method name, then the parentheses, and inside the parentheses is your parameter list, right? Which is just the types and the name of the parameters. Okay, so that parameter list, inside that parameter list, it's the same rules that you have in C, right? The names in the parameter list have to be unique, right? So that's x and y. It can't be y and y or x and x, right? In Java, the name of the method followed by the types in the parameter list is called the signature of the method. So the signature of set is set double double. Right? So the types of the parameters, they stay, you have to keep them in the same order. The signature turns out to be important in Java. Right? So in other examples of signatures, right, in the string class, you've got a to uppercase method. Right? So the signature, you ignore the return type. Right? So it's just the name and the parameter list. Right? So car at would be car at int. Right? Index of is index of string and then int. Right? And get cars would be get cars int, int, array of car, int. Right? So the names of the parameters don't matter. The return type doesn't matter for the signature. Right? Now, what's the signature used for in Java? So the rule in Java is for the methods in your class, the signatures must be unique. The names don't have to be unique, but the signatures have to be unique. Right? So I've got a method called set in the class already. Right? Its signature is set double double. That means I'm allowed to add another method called set as long as its parameter list is not double double. Right? So set double is fine. Right? And this particular version of set, apparently it just sets the x coordinate and makes the y coordinate equal to 0. Right? If I add that version of set, I cannot add the second version of set, the third version of set, right? Because its signature is also set double. Right? And so that's illegal. If you have two methods with the same name but different signatures, Java says that those methods are overloaded. Right? So here I've got three methods called distance2. Right? Their parameter lists are all different. Right? So float, float, double, double, and point2. Right? So that's three different methods with three different signatures. So I could put all three into the class if I wanted to. Right? Presumably distance2 calculates the distance between the point and another point x, y, or another point p. Right? So if you wanted to, you could add all three of these methods to the class, and that would be fine. Right? And in Java, it's quite common to see a class with many different, with several different methods all having the same name. Yeah?
But it's fine if you just change the name, right?
You can also just change the name, yes. So for example, the string class has many, many versions of the method called value of. Right? So there's a value, so there's at least 8, there's 9. So there's one for every primitive type. And then there's another, oh no, so there's at least 8, one for every primitive type. Yeah. Right. And so it's very common, especially in most object-oriented programming languages, that you are allowed to have the same method name, but the parameter lists are different. Okay, so this is the same rule that's in C, right? If you have a function in C, it either returns a value or it returns void. Exact same thing is true in Java. Okay, so methods common to all classes. Now remember the string class has a method called equals, right? So if you want to test two strings to see if they're the same, they represent the same sequence of characters, then you use the equals method. Right? It turns out you can use equals for any object. Right? In other words, if you have an object, you can ask if it's equal to any other object in Java. The reason that works is because all objects in Java are actually what are called subclasses of this thing here. Right? So java.lang.object is considered to be the parent class or the superclass of all classes in Java. Right? All that means is that whatever is in object is also in every object in Java. Right? So when we make our point2 class, if I make a point2 object, whatever is inside big O object is also inside of our point2 object. Right? And that means whatever methods object has, big O object has, our class also has. Right? So our point2 class has every public method that object has. Right? And it turns out that in the class big O object, there's a method called equals. Right? And that's why you can call equals on any object reference in Java. Right? There's also a toString, which is why you can print any object in Java. Right? So when you print an object in Java using printline or print, all that the printline or print method does is it calls toString on your object and then prints the string that it gets back from the method. Right? Hash code we'll look at in a little bit. OK, so toString is useful. So the fact that you can print any object in Java makes it super useful, especially for debugging. Right? What does toString do? So toString is supposed to return a string or text representation of an object. Right? Now, if you're implementing your own class, you get to decide what is the string representation of your object. Right? So for points, right, we get to decide what do I want a point to look like when I print it. Right? So if I print the point -1, 1.5, maybe we should print the point that way. Right? So inside round brackets, we print the x coordinate followed by a comma, followed by a space, followed by the y coordinate. Right? You might do it differently depending on the, what you're using points for. Right? If you're a mathematician, you might use square brackets to indicate that it's a vector. Right? And then you might put the -1 and then a space and then a 1.5. Right? Or something else. Right? So we're going to generate the string representation for our points like that. OK, so how do you do this? Well, you just replace the definition of toString that you get from object. Right? So what does toString look like in object? It looks like public string toString. Right? No arguments. Right? How do I generate the string? Well, it's pretty easy. Right? It's opening round bracket. Right? Concatenate that with the x coordinate. Right? Concatenate that with a comma and space. Concatenate that with the y coordinate. And then concatenate that with the closing round bracket. And that's it. Right? So it's normally relatively straightforward to produce a string representation of your object. Right? OK, so what's this funny @ override? Right? If you ever see an @ inside of your source code, right, unless it's in a comment like that, right? So if you see an @ that's not in your source code somewhere, that's what Java calls an annotation. So an annotation is something that the compiler can see, right? And then the compiler will do something based on what that annotation is. So the @ override annotation tells the compiler to please check, is there a method public string toString in the class big O object? Right? If there isn't, it'll complain. It'll say, hey, you're trying to replace the definition of toString, but there is no method in object that looks like public string toString. Right? So for example, if I change this public to private and tried to compile this program, the compiler would refuse to compile it. Right? If I change the return type to something, again, the compiler would refuse to compile it. If I misspell toString, again, the compiler will say that that's an error. Right? If you leave off the @ override, and this is correct, then everything works the way you expect it to. Right? If you leave off the @ override and something is wrong here, and then what ends up happening is you don't replace the version of toString from object. You end up creating a new method. Right? So the @override here is for the programmer's benefit, right? It's just a little safety net to test if in fact you are replacing a method correctly. Okay. You have a question, or do you just? No, sorry. Yeah, it's just that your hand was.
Oh, sorry.
It's okay. I was just checking if you had a question. All right. So again, @override is optional. You have a question? Okay. All right.
How does this work if you're trying to like convert to string like with anything that's not your point time? Because this seems like it would only work for like how does it know how to do any other object than the one that you're redefining it for?
So every other class
Yeah.
will either replace the definition of toString. So they'll do exactly what we did here. So inside the class will be a new definition of toString. Or if there is no new definition, it ends up using the definition from big O object.
Oh, okay.
All right, so by providing a toString method, now people can print Now people can print our point2 objects. Right. So if we make a point2 object, set its coordinates to -1 and 1.5, you can now print the point just by calling p.toString. You don't even need the toString. Right. You can leave off the toString and println. Right. So there's an overloaded version of println that will take in any object reference. Right. Inside println, it calls toString for you with your object reference. Right. This version of println is the one that takes in a string. Right. And so it prints the string. Okay. So we can also add methods to our counter class. Right? So remember, our counter is just a thing that counts up by 1. Right? So if you're implementing a counter, what do you want people to do with the counter? Well, they probably want to get the value of the counter. Right? They probably want to advance the counter by 1. And they might want to be able to get a printable version of a counter. Right? So let's go ahead and implement those methods. Right? So we'll make a method called value. So this is our accessor method that returns the value of the counter. Right? It returns an int because that's what the value is. Right? So that's a one-line method. You just return this dot value. Right? Okay, so advance is a mutator method, right? So because it does change the state of the object. Right? So advance, the contract or the specification for advance is up here in the comment. Right? So advance says that it increments the value of the counter up by 1. Right? If the method is called when the current value of the counter is integer max value, then the value of the counter wraps around to 0. Right? It doesn't wrap around to to integer min value. Right? It wraps around to 0. And so the counter class promises that its value is always non-negative. Right? So in order to implement this method, we have to test, right? Is the value not already integer max value? Right? If it is, go ahead and add 1 to the value. Right? Otherwise, set the value to 0. Right? Now, so this is a correct way to implement the method. It's very easy to screw this method up. Right? So it's not uncommon to see the following implementation of advance. Right? So instead of testing the value first, right, it's not uncommon for programmers to just increment the value and then try to do something like this. Max. Right? So instead of implementing it like that, right, we'll increment the value by 1, right, and then try to test, is the value greater than integer max value? Right? This doesn't work. Right? Why doesn't it work? Because that's an int. Right? And the largest possible int is integer max value. Right? So that condition is never true. Right? And your counter never gets reset to 0. Right? So whenever you're working with ints and you're trying to test, can you increase or decrease the value of the int beyond the range, right? You have to test that first before adjusting the value, right? You could, I suppose, fix this, although it's not a great fix, right? So you could do something like if the value is less than 0. Oh, there's a round bracket missing, right? I guess technically that works, right? Because if this thing wraps around, it'll wrap around to a large negative value, right? So if you ever detect a negative value, you can just set it back to 0. So I suppose technically this works, but you really should test if you can adjust the value first, and then do so if you can. Okay, now what about toString? So when you implement toString, it's up to you how you generate the string representation of your object. Right, so here I'm just going to use the word count, followed by a colon, followed by a space, followed by the count. Right? But you could choose a different way of doing this, right? So you could put the count in square brackets, you could put it inside braces, or whatever you wanted to. Right? It's up to you when you design your toString method. Okay, what about that stopwatch? So the stopwatch, to make the class usable, you want to add a method that lets the user start the watch. Right? You want to add a method that lets the user stop the watch. And then you want to add a method that lets the user find out how much time has elapsed. Right? So for the elapsed time, there's two different cases. Right? If the watch is running, then the elapsed time is the amount of time that has elapsed since they pressed start. Right? And if the watch is not running, then the elapsed time is the amount of time between pressing start and stop. Okay, so inside the stopwatch class, there's our constructor. I've added a private constant called 1 billion, or called billion. Right? The billion is there because I want to convert between seconds and nanoseconds. Right? So add a method that starts the watch. Right? Okay, so how does this work? So starts the stopwatch. It does nothing if the stopwatch is already running. Right? So if the watch is not running, go ahead and start the watch. Right? So when you start the watch, you set the start time. Right? We set the start time by calling nanotime. Right? And then change is running to true. Right? If the watch is running, nothing happens and the method returns. What about stopping the watch? Okay, so when we stop the watch, right, it stops the stopwatch and returns the elapsed time in seconds since the watch was started. Right? If the watch is already stopped, then the elapsed time in seconds as computed by the method elapsed is returned. Right? So if the watch is running, stop the watch. Right? To stop the watch, you set the stop time. And again, you do that by calling nanotime. Right? And then set is running to false. Right? After doing that, you return the elapsed time. Right? To do that, I'm just going to call the method called elapsed and let it take care of returning the elapsed time. So for the elapsed time method, right, if the stopwatch is running, the method returns the total amount of time in seconds that have elapsed since the stopwatch was started. Right? If the watch is stopped, then the method returns the total amount of time between the start time and stop time. Right? First of all, we get the current time. Right? And you get the current time by calling nanotime again. Right? If the watch is stopped, then I'm just going to replace current time with the stop time. Right? And now I have the current time, so I can compute the total amount of elapsed time by taking the current time minus the start time, and then dividing by 1 billion to get the time in seconds. Right? Now, when I do this, I have to make sure that either the numerator or the denominator is a double. Right? Because current time is a long, start time is a long, so that right there, that's a long value. Billion is also a long value. Right? So if you don't convert one of those two values to double, this gets done using integer division. Right? And you just get an integer number for the seconds, which probably isn't what you want. Right? You probably want like something point, something seconds. So to convert the numerator to a double, I add 0.0 to the front at the very beginning. Right? You could also cast current time, or you could cast start time. or you could cast a billion to double, and all of those would work in this case. Right? Okay, more constructors. So you can add multiple constructors to a class, and it's often the case that a class will have multiple constructors. When you add multiple constructors, the signatures of the constructors must be unique. Right? Now, all constructors have the same name, so that means the parameter lists have to be different. So for point 2, right, it's useful for users of the point 2 class if they can specify the x and y coordinate when they make the point. Right? So if you want to add a constructor where the user can specify the x and y coordinate of the point, right, you just add a constructor that takes in an x and a y value, right, and then inside the body of the constructor, right, you set this x to x, and you set this y to y. Right? Now, in this example here, you have to write this dot x and this dot y, right? Because there's a parameter called x, and there's a parameter called y, right? The parameter names match the field names, right? So when parameter names match the field names, the parameter names take precedence. Right? So inside the method, inside the constructor body, when you just write x, you mean the parameter x, and when you just write y, you mean the parameter y. Right? So if I want to set the field called x, I have to write this dot x, right? And if I want to set the field called y, I have to write this dot y here. We've seen this picture before, right? So it's all the same thing all over again. All right. So in that constructor, because the parameter names match the field names, the language has to decide which names get precedence, right? And the language says the parameter names get precedence. So when this happens, we say that the parameters shadow or hide the fields. Right? And when shadowing occurs, that's when you have to use this dot. You have to use this dot to refer to the fields instead of the parameter names. Right? And it turns out in Java this happens a lot. Right? So it's very common that someone makes a method or a constructor where the parameter names match the field names. Right? Okay, so after adding that constructor, it's now easy for people to make points, having specified coordinates. Right? So before, you'd have to make a point, and then you'd have to change the coordinates of the point. Right? Now you can just make the point, and with the coordinates specified right from the beginning. Right. Okay, what about copy constructor? So a copy constructor makes initializes a new object by copying the state of an existing object. Right? And you can tell it's a copy constructor because it always has one parameter, and the type of the parameter is always the same as the class. Right? So for the point 2 copy constructor, right, it's got one parameter, and its type is the same as the class that it's in. Right? So to copy the state of the other point, right, I want to set the x coordinate of this point to the x coordinate of the other point. Now notice here, I can access the x coordinate of the other point directly by name. Right? So I can actually write other.x. Right? The reason I'm allowed to do this is because I'm in the point 2 class. Right? So other is a point 2 object. Because I'm inside the class, point 2, I'm allowed to go in and access its field directly. Right? Even though x is private. Right? Inside the class, you're allowed to access the private fields or private features of another object, of another point 2 object. Right? So I can just write other.x here. And similarly, I can just write other.y there. Right? And again, so why add a copy constructor? Because it lets people more easily use your class. Right? So here's an example here, right, where we make a point, P, right, and then I make a copy of the point called Q right there. If I didn't have the copy constructor, you'd have to do something like this. Right? The user would have to call a different constructor, this time extracting the coordinates of x and y themselves. Right? So by providing a copy constructor, that saves the user from having to write in that stuff there. Right? Now the copy constructor makes, when you use a copy constructor, you end up with a second independent object. Right? So P and Q, right, they refer to two different objects. If I print out P and Q, right, they both have the same coordinates. If I change P, right, if I change the coordinates of P and then print out P and Q again, right, P changes but Q doesn't. Right? So P and Q really are two independent objects with their own independent state. Right? How does it work? Right? The P object has its own x and y field, right? And the Q object has its own x and y field. Right? Changing P doesn't change Q. Right? And that's why we make objects. Right? So you have multiple instances with their own independent states. All right, so in your constructors, every constructor does the same thing, right? It sets the fields of the object, right? So all of our constructors for the point2 class, right, they consist of two lines of code, and the two lines of code are just this.x equals something and this.y equals something, right? So whenever you see duplicated code, right, at some point someone should have told you you should consider moving that duplicated code into a common method, right? And just call the method instead, right? Now in this case, one of our constructors already does everything we need to do. So when you're implementing constructors, it's usually the case that one of the constructors is the quote-unquote most general constructor, right? So for example here, right, this version of point2, this constructor here, this is the most general form of the constructor, right? It takes in the two coordinates x and y, right? So it would be nice if there was a way for the first constructor to call the second constructor, right? Perhaps passing in 0 and 0 to initialize the point, right? And similarly, it would be nice if this constructor could also call the second constructor, perhaps passing in other x and other y, right? And so there is a way to do it. So the way to do it is with what is called constructor chaining. So a constructor is allowed to call another constructor, but there are some rules about when you can do this. Right? So if inside of a constructor you want to call another constructor, that's called constructor chaining. The only place you can do this is on the first line of the constructor body. Right? So that's the only place you're allowed to do it. You can't do it inside of a method, and you can't do it on any other line inside of a constructor. The way you do it is you use the keyword this, which is slightly unfortunate, right? So now this has another meaning. So you have to infer the meaning based on the context, right? So you use this instead of the name of the constructor, right? So the way you do it is as follows, right? So for the no argument constructor, I want to set the coordinates of the point to 0, 0. One way to do it is to call this constructor, passing in 0 and 0, right? So the syntax is on the first line, you write this, round bracket, 0, 0, right? That causes the second constructor to run, which sets this x to 0 and sets this y to 0, right? You are allowed to have code after the chain to the constructor, right? So if you need to do extra work right here, you can go ahead and add in extra code right there, right? Similarly for the copy constructor, right, I can call the second constructor passing in other x and other y, right? So that line there calls this constructor here, right? This constructor sets this x to other x and this y to other y. If you need extra code here, you can go ahead and put in extra code there, right? So the constructor chain in this case doesn't really save you any work, right? You basically save one line of code there and you save one line of code there. And arguably, you had to write more code, right? So this doesn't save you any work, right? Mostly because this class is so simple, right? There's only two fields. When you implement a more complicated class that has more fields, right? Or when assigning the fields becomes more complicated, right? That's when constructor chaining actually helps you do something useful. So in the counter class, we can also add more constructors, right? We can add a constructor that initializes the counter to some specified positive value, right? So make a counter that starts counting from some positive value instead of 0. And we can add a copy constructor, right? And just for fun, we can use constructor chaining to do all of this. Right? So back to the original counter class, right? I'm going to add a second constructor that lets me specify the starting value of the counter. So I'm going to change the no argument constructor to use that second constructor. Right? The second constructor just looks like this. Right? So the second constructor takes in a value. Right? Eventually, it sets this value to equal that value. But our counter class has what's called, our counter class promises that the value of the counter is never negative. So we have to check, is the incoming value negative? Right? And if it is, we have to indicate that that's not allowed. Right? And so we throw in an illegal argument exception in this case. Right? Now, when the exception is thrown, the constructor stops running. Right? And the object is never fully initialized. Right? For the copy constructor, we just want to copy the value of the other counter. Right? So again, we can use constructor chaining, pass in other value. The second constructor will run, check the value, and then assign the value. Right? So this is an example of using constructor chaining where it's actually a bad idea to use constructor chaining. Right? Why is it a bad idea? Right? So for the no argument constructor, you're going to set the value to 0. Right? We know that 0 is a valid value for the counter. Right? If you use constructor chaining, though, the first thing that constructor does is it tests the value of 0. Right? So in other words, it needlessly tests a legal value. Right? And so you end up paying the price of this if statement when you don't have to. Right? Similarly, if you're copying an existing counter and the counter class is implemented correctly, you know that that value is not negative. Right? So you really don't need to make this test again. So again, you end up paying the price of a needless test because we use constructor chaining here. Right? So chaining doesn't always save you work, and sometimes it causes you to do more work. Which in this example, that happens. Right. All right, I think that's enough for today. We'll move on to the next deck of slides in the next lecture. I guess I'll see you on Tuesday. So have a good weekend.